So in the last lecture, we discussed the indirect routing, right? So how does the correspondent send its packets, send the datagrams to the mobile in a visited network, in a network different than its home network? So what happens is that the whole thing is transparent to the correspondent. Correspondent addresses the packets using the home address of the mobile as if the mobile is in its home network. And because the home agent here knows that the mobile is not here, and it also has its care of address, that COA. This is done with the mobile registration protocol that we are going to learn shortly. So it intercepts the packets and tunnels them to the foreign agent, and then foreign agent forwards them to the mobile, and the mobile responds directly to the correspondent if the correspondent is not mobile, because it knows its address anyway. Okay, so this was indirect routing. So the whole thing is transparent to the correspondent, and the care of address is used by the home agent to forward packets. So one problem here is this triangle routing problem. It's not a problem, but it is inefficient. So everything, when you draw all the routes, it looks like a triangle, right? That's where the name comes from. But if the correspondent is actually very close to the mobile node here, even though they can communicate directly without even maybe going through the whole internet if they're in the same local network, still everything needs to go through the home agent. So they have to go all the way to the home agent, and that home agent needs to tunnel it back to the foreign agent. So this can be inefficient if the correspondent and the mobile are close. Okay. So we discussed all that. So to solve that, to overcome the inefficiency of that triangle routing problem of indirect routing, we have mobility with direct routing. So the difference here is that instead of tunneling packets to the foreign agent, this home agent just sends the foreign address of the mobile directly to the correspondent. So correspondent first requests and then receives the foreign address of the mobile, and then all the packets are directly sent, directly forwarded from the correspondent to the foreign agent. So in number 3 here. Okay, so the only job of this home agent here is to keep record of where the mobile node is, the care of address of the mobile node, and then responding to the correspondence that request that. And again, after the mobile node receives the packets, if it wants to reply, it can just directly send the reply to the correspondent. The foreign address is the temporary address of the mobile. Yeah, so we call that the care of address. That is the temporary address of the mobile dependent on the network visited. So it is either assigned by the foreign agent, or it can be chosen using some kind of DHCP protocol by the mobile. Okay. So this direct routing overcomes the triangle routing problem. And this is not unlike the indirect routing problem, which is transparent to the correspondent. The correspondent doesn't even know that the mobile node is somewhere else. It doesn't know where it is. It doesn't know the care of address of the mobile node. In direct routing, this whole thing is not transparent to the correspondent, because the correspondent must get the care of address from the home agent. But this raises another issue here. So what if the mobile here changes the visited network? This correspondent learned about the current care of address, but what if this mobile goes to another network and changes its care of address? So when that happens, all that data then needs to be sent to the new foreign network, right? So this, instead of 3 datagram 3 sending here, it has to send here. But in the case of indirect routing, this was not a problem because the datagrams always go through the home agent, and the home agent knows the updated care of address through the mobile IP registration protocol. But with direct routing, this home agent is queried by the correspondent only once at the beginning of the session. So this 1 and 2 only happens at the beginning of the session. So what happens if that mobile moves to another network? That correspondent won't know the new care of address. Well, one easy fix is to create a new protocol to notify the correspondent about the changing care of address. So in this concept, we have something called the anchor foreign agent. And it is treated kind of like the new home agent of the mobile node. This is still the foreign agent, but the first foreign agent visited, okay? This is the first foreign agent visited by the mobile. So the mobile was here, and then it is moving to a new network. What happens here? So in step 2 here, the mobile node moves to a new foreign network, and it registers with the new foreign agent in number 3. So after that registration is done, this new foreign agent informs the anchor foreign agent. Okay, so it provides the anchor foreign agent with the new care of address of the mobile, new care of address provided by the new foreign agent. So now the anchor foreign agent knows the new care of address, right? So when the correspondent wants to communicate with the mobile node now, it just sends the packets to the anchor foreign agent. Everything goes through the anchor foreign agent, and then the foreign agent tunnels the packets to the mobile node. And if this mobile node moves to another network, new foreign agents are just chained here. So everything goes through the anchor foreign agent, and then the new foreign agent, and the new foreign agent, new foreign agent. Okay, it's a chaining approach here. Could you repeat what was the role of the anchor foreign agent? Sure. So this anchor foreign agent keeps track of the care of address of the mobile. So whenever mobile moves to a new foreign network, the care of address provided by the new foreign network is always sent to this anchor foreign agent, and foreign agent always keeps track of COA. So just like the home agent of the indirect routing, it keeps track of the COA and performs kind of indirect routing. It's not called indirect routing, but it's like the indirect routing of the earlier example we've seen. So then everything goes through this anchor foreign agent. It tunnels the packets to the mobile node. So when does this anchor foreign agent change? Well, it doesn't change. So it is the first foreign agent visited by this mobile network. Okay. Well, but of course, if it doesn't have to stay as the anchor foreign agent all the time. So if somehow this mobile agent registers with, let's say it went to the home address and then went to a new foreign agent, that new foreign agent can assume the duty of the anchor foreign agent. But this is, so in this example, we're thinking about a sudden change of the mobile, sudden change of the location by the mobile. So mobile immediately moves into a new network before even correspondent even updated the new care of address. If the correspondent didn't update the new care of address, it only knows the anchor foreign agent's care of address. So who becomes the anchor foreign agent? It is the first foreign agent visited by the mobile, but it is also the foreign agent that provided the foreign agent whose COA is provided to the correspondent. So remember, there is this home agent here. It provides the correspondent with the COA. So that COA is the COA of the anchor foreign agent. Another question is, does that mean there is some protocol that always run the anchor foreign agent all the time in the background? Yeah, so for instance, there is this registration protocol here. So whenever a new foreign agent comes, the new COA has to be updated with the anchor foreign agent. And also the anchor foreign agent needs to tunnel packets all the time. So these are some protocols that needs to be run by the anchor foreign agent. Okay. All right. So we have seen the direct and indirect routing and how they work, but all these internet protocols that support mobility and enable direct and indirect routing are called mobile IP protocols. So next we are going to discuss some of the modes of operation under this mobile IP. So another question is, what happens when anchor foreign agent gets disconnected? Well, if it gets disconnected, I assume because the correspondent isn't updated with the new, I'm sorry, if anchor foreign agent gets disconnected, nothing can go through this anchor foreign agent. So until it's connected again, I assume that the connection to the mobile is lost, unless the correspondent can somehow get the updated COA of the new foreign network. So that's just my guess. All right, so let's now see all these internet protocols that enable mobility in the internet. So mobile IP protocols are also defined in the RFC, request for comments, but our purpose here is to learn just a few important aspects of mobile IP over a few examples of common case scenarios, rather than just going through everything there. So the mobile IP architecture contains many of the features and elements we have discussed, including some of the concepts like home agents, foreign agents, the registration of care of addresses, and also the encapsulation, how the home agent tunnels packets to the foreign agent. And there are three main components to mobile IP. The first one here is agent discovery, and it defines the protocols used by home agents and foreign agents to advertise their services to the mobile nodes. And also it defines the protocols for mobile nodes to request the services of agents. The second one here is registration with the home agent. So whenever the mobile node visits a new network, its new care of address has to be registered with the home agent. So this registration with the home agent defines the protocols used by the mobile node to register care of addresses. And we have also the indirect routing of datagrams. So as we have seen, these are just the rules for forwarding datagrams and their encapsulations. Another question here is, previously when we learned about direct and indirect routing is part of mobile IP, or it was just some general topic? So these are parts of mobile IP, or rather these are how routing works. And the reason they work is that we have a collection of protocols called mobile IP. So the mobile IP protocols are the enablers of direct and indirect routing. Okay, so that's the same topic, but now we are going to see the protocol, how it actually works. Who tells what? What's the sequence? What are the headers? What information exactly is exchanged? Okay. So let's start with the agent discovery. So as we have seen in both direct and indirect routing, so when a mobile node arrives to a new network, we said that it obtains a care of address from the foreign network, right? So this defines how that care of address is obtained. So let's say mobile arrived to a network, be it a home network or a foreign network, and it needs to learn the identity of the new agent and needs to obtain a COA if it's a foreign network. So one way to learn about the new agent is by listening to the advertisements by the agents. So all the agents make regular advertisements by broadcasting ICMP messages with the type field 9. So type field, where is type field 9? So ICMP is just Internet Control Message Protocol. So all the details are not important, but maybe let's go through some of the relevant ones to us here, relevant to mobile IP. So the agents periodically broadcast ICMP messages, and this router discovery message contains the IP address of the router here, okay? And some other fields here, the home agent bit, indicating this is the home agent for the foreign network. Sorry, this is the home agent for the network in which the mobile resides, or whether this is a foreign network, indicates that the agent is a foreign agent for the network it resides. So this is indicating whether the agent is home agent or the foreign agent. It's not for the visiting node. And there is also this registration required bit. So it indicates that a mobile user first, it needs to register with the foreign agent. If this is a foreign agent to the mobile node, mobile node cannot use it. I mean, if this registration bit required is 1, it means that the mobile user cannot obtain the care of address itself using maybe DHCP protocol, but instead it has to first register with the foreign agent. So in the previous examples that we have seen, the foreign agent assumed all the duty of forwarding packets to and from the mobile node, right? So that is registration bit required, that means. If this is not required, the mobile user can assume the functionalities, some of the functionalities of the foreign agent for itself. So it can just directly get packets from the home agent without packets needing to go through the foreign agent, okay? So this is what this registration required bit defines. Right, so this is agent advertisement, and this is just one of the 2 methods of agent discovery, and this is how it's usually done. But there is also alternative to it. So that's called agent solicitation. And if the mobile node wants to learn about the agents without waiting to receive the agent advertisement, then they can do agent solicitation and they can broadcast the agent solicitation message. So if they are in urgent need of to find an agent, let's say they are maintaining a call there, they have to maintain a TCP connection and they don't want to wait for the agent advertisement message, they can do agent solicitation. Okay, so in the previous slide, we have seen the agent advertisement. Now, let's say the advertisement is done and the mobile agent obtained a care of address from a foreign agent. Okay, this is the care of address obtained by this mobile agent from this foreign agent. And this mobile agent also has a permanent address. Here we refer to it as the mobile address, but this is the permanent address. Let me write here also, PA. So this has the same subnet IP as the home agent, as you see here. And now we want to see how registration with the home agent is done under the mobile IP. So once that mobile node receives a care of address, that address needs to be registered with the home agent. Okay, so that care of address is obtained with the ICMP agent advertisement. And then the mobile agent starts registration process. It sends a registration message to the foreign agent with these fields: the care of address, the address of the home agent, and the permanent address of the mobile, and some lifetime, how long this care of address will be valid for, and just some identification that will be repeated in every following message. So now the foreign agent receives this registration message and records the mobile node's permanent address. The foreign agent now knows that it should be looking for datagrams containing an encapsulated datagram with the destination address shown as here, same as the permanent address of the mobile agent. And then that foreign agent forwards that to the home agent for home agent to learn the care of address. The datagrams from there on, datagrams addressing the permanent address of the mobile will now be encapsulated and tunneled to this care of address by the home agent. Okay, assuming this is indirect routing. And then just home agent sends a reply, and then that reply is forwarded to the mobile agent. So at the end of this protocol, the registration protocol, what happened? The home agent learned the care of address, and the foreign agent learned the permanent address. So now they can do the tunneling and forwarding to the mobile agent. What do you mean by encapsulation? So yeah, in the last lecture, we discussed that in the indirect routing, but okay, we have one more slide here anyway. So let's discuss on here. I'm just gonna show encapsulation here. Another question, why the datagram that is sent to the home agent also include mobile permanent address? Well, it's just how this registration message is structured. So it's the same message being forwarded and being forwarded by the foreign agent. So of course, the home agent doesn't need to know the permanent address, but it is put in there for the foreign agent and the same message forwarded to the home agent. But you're right in saying that this permanent address is already known by the home agent. In that case, the correspondent would know the permanent address and no need home agent anymore. Well, we still need the home agents, right? Because if we have a correspondent that wants to connect to this mobile, it only knows the permanent address of the mobile. So when it sends packets to this mobile, the internet routes it to the home agent, and then the home agent has to tunnel it to the mobile agent. So the correspondent would know the permanent address and no need home agent. No, we still need the home agent. Another question is, why is the lifetime fields in registration reply different from registration required? So there is this lifetime field, and I don't see any relation to the registration required. So in this example, this registration required is a part of the agent discovery protocol. This is the ICMP message, and it's used for agent discovery. So in this slide, however, we have already done the agent discovery, and we are doing registration. The agent the care of address registration with the home agent. Ah, okay. You mean this one? Okay, I see. So this is 499, this is 999. Well, okay. So this is the desired lifetime by the mobile agent. And this is for how long this home agent is going to record it for. So if this is 499, then home agent will have to update the home agent again when this expires. So this is just the preference, and this 499 is what's set by the home agent. But I mean, even before this lifetime expires, if this mobile agent goes to a new network, then this old care of address will be void. So RFC stands for request for comments. So it's the set of documents that defines most of the protocols used in the internet, the open protocols available for access. This request for comments document. So another question is, the home agent does not directly send the datagram to the mobile. Well, yeah, so it goes through the foreign agent, but if the mobile agent assumes the duty of the foreign agent, in some scenarios it can do so, we didn't discuss that, then it can directly send it to the mobile. But of course, it has to go through some of the routers. By directly, it means that the encapsulation is done by the mobile agent in that case. Continuing to that question, it will send to the foreign agent, and then the foreign agent will send the datagram to the mobile. Yes, that's the scenario we discussed, and I think for the sake of this class, that's sufficient. But as I said, in some scenarios, if registration with the foreign agent is not required, that mobile agent itself, that mobile node itself, can assume the duty of the foreign agent. Okay, so now let's see how encapsulation is done in the indirect route. Okay, so correspondent first sends the packets with the destination address same as the permanent address of the mobile. And then that home agent encapsulates that original datagram here into a new datagram with the destination address same as the care of address registered with the home address. In the previous slide, we saw how care of address is registered, and here we see how it is used by the home agent to encapsulate the original datagram. And when that encapsulated datagram reaches the foreign agent just drops the altered datagram and sends the original datagram sent by the correspondent to the mobile. Again, this is indirect routing example. Everything is transparent to the correspondent. Okay. Yep. Okay, so we saw direct and indirect routing and how those are enabled in the internet using a set of protocols called mobile IP. Well, as cellular networks is also a type of network, mobility is also handled in the cellular networks in a similar way. So the fundamental principles are very similar. Here, the home network is the cellular provider which the mobile user has a subscription for, say Singtel or StarHub or M1 or something. And when it visits another network, they use similar protocols. Some keywords are different, some concepts are slightly different. But because in this class we want to learn about the fundamental principles, I will not go through handling mobility in cellular networks. And another reason for that is that some of the things change over time. So you can read about how it works in the GSM, the 2G network, or when you make a phone call using a mobile phone, that's how it goes. But in 4G and 5G, it's a bit different. So if you're interested in this, you can read your book. So I think in the earlier editions, in the 6th edition or earlier, you have handling mobility in GSM. And I think after 7th or 8th edition, you have handling mobility in 4G. So there are some differences. So we are not going through this in the class, but maybe let's just go through the handoff in cellular networks, the handoff problem, because we didn't see that in the mobile IP protocols. So in cellular networks, we have a higher degree of mobility. So by the way, this MSC is the mobile switching center, this guy here. So it acts like the control center for the network switching system, and it connects the calls between different subscribers by choosing the correct network paths. So our handoff goal is that if a mobile user is speeding from a base station to another base station, how do we route the call through the new base station without interruptions? Okay. And the GSM doesn't mandate when we should do the handoff or why we should do the handoff. It only tells us how to do it. So there can be many reasons for the handoff. It can be because there is a stronger signal from the new base station and less signal from the old base station, and our mobile user doesn't want to spend too much energy transmitting signals. It can also be due to load balancing. So if this old base station has too many users around, it may want to free up some channels so it can send this mobile user to a new base station. Or it can be due to some cell size adaptation. If this old base station has a very large cell serving too many users and new base station has very few of them and have available radio resources, that can happen. Okay, so now let's see how that works. So it all begins by the mobile node measuring the strength of the beacons from the current base station and the nearby base station. So it periodically does that. And it periodically also reports them to the current base station it is connected to. And the handoff then is initiated by the current base station, or soon to be old base station. Okay. So first, the base station informs the mobile switching center about the impeding handoff, and it provides a list of at least one new base stations for the mobile to connect to. And this mobile switching center then sets up paths, meaning that it allocates resources to the new base station here. And that new base station allocates the radio resources by the use for the mobile. Remember, so this is because this is a wireless medium, it has to allocate radio resources, either time, frequency, or CDMA. And the new base station then signals the mobile switching center and the old base station that it is ready for the handover in item 4. And then in 5, the old station tells the mobile that it can now perform the handoff to the new base station. And then the mobile activates the channels with the new base station because it already has allocated resources here. And then mobile tells the mobile switching center through the new base station that the handoff is complete. So mobile switching center can now reroute the call so it can send the incoming data packets this way. And finally, the resources for the old base station are released by the mobile switching center. Okay. So one question is the idea of mobile IP. Is it when our PC change IP address dynamically when we visit different website? Not really. I'm not sure what you mean by your PC changing IP dynamically when you visit different website. But so the idea of mobile IP is when you visit a different network. It can be in the case of mobile, it can be a different service provider, different ISP. It can be a different country. Your permanent address has to stay same, and then you are assigned a new care of address. So the point is for anyone that wants to connect to you, that wants to send packets to you, finding the correct route in the internet, in all the routers, in all the autonomous systems, finding the correct route to your new care of address. So that's the idea of mobile IP. Okay. Okay, so this concludes our study of wireless and mobile networks. So the routing is still in the internet. Yes, routing is still in the internet. So yeah, we concluded our study of wireless and mobile networks. So to briefly go over what we discussed, you learned about some key concepts like infrastructure mode, ad hoc mode, wireless hosts. We discussed the Wi-Fi 802.11 protocol and learned about carrier sense multiple access, collision detection rather than collision avoidance of the Ethernet. We learned about the CDMA, code division multiple access, which is an alternative to TDMA and FDMA, time division multiple access and frequency division multiple access. And about mobility, we learned about mobility management principles, direct and indirect routing, how a new agent is advertised, how registration with the home agent is done, and finally, how the encapsulation for indirect routing is done. All these are defined under mobile IP protocols. And finally, we briefly looked at the GSM handoff. And if you're interested in how mobile IP is handled in cellular networks, you can have a look at the book.